We continue looking at the limit theorem. We have looked at an example of the first result and the second result. We want to look at an example of the third result. Alright? Now, if we have, say, an is equal to 7 plus 1 over n, and bn is equal to, say, 3 plus 1 over 2 to the n. Now, when we divide an by bn, what we have is an divided by bn equals is going to be 7 plus 1 over n divided by bn, which is 3 plus 1 over 2 to the n. What is the limit as n tends to infinity? Let's see. This is 7 plus. As n gets larger and larger, 1 over n gets smaller and smaller, so this will tend to 0, divided by, as n gets larger and larger, here, 2 to the power of n will become larger and larger. You see that? While 1 over that larger number would result in a smaller and smaller answer. So we have 3 plus 0. So the limit of an divided by bn is 7/3. 7 over 3. Now, that's the limit of an over bn. For our example, it is 7/3. Let us look at each expression by itself now. What's the limit of this as n tend to infinity? It is 7 plus, as n tend to infinity, 1 over n tends to 0. And the limit of bn as n tend to infinity is 3 plus, as n tend to infinity, 2 to the n tends to infinity, and 1 over that tends to 0. So what we have is 7/3, 7 over 3. See, 7 over 3. So an is equal to bn. And the limit of an is 7, and the limit of bn is 3. So it is 7 divided by 3. So there we have an example of the third result. Alright? Let's look at the fourth result. It says the modulus of the limit of the modulus of an is equal to the modulus of the limit of an, which is equal to the modulus of an. Let's see an example of that. Suppose an is equal to, let's say, 7 over n minus 5. Alright? 7 over n minus 5. Now, this here, if we have the negative value of this and we take the modulus, it will become the positive value, right? Now, the limit of a positive value of this. Let's see the first few terms of this. A1 would be 7 over 1 minus 5, which is negative 2. A2 would be 7 over 2 minus 5, which is what? 7 over 2 minus 5. Let's look at our calculator. So 7 over 2 equal 3.5. 3.5 minus 5 equal negative 1.5. So what we have is negative 1.5. What about A3? A3 will become, or let's speed it up a bit. What would let me see now, A what? A70 be? What is A70? It is 7 over 70. Whenever I have the calculator on, it slows down everything. So let me remove it. Alright, I can write faster now. I had to write slow a while ago. 7 over 70 minus 5 is equal to 1/10 minus 5. What is 1/10 minus 5? 1 over 10 minus 5 over 1. This is the same as 1/10 minus 50/10. Alright? So in this case, we have negative 49/10, which is negative 4.9. Negative 4.9. And on it goes. Now, here, if we take the modulus, first of all, as we go on and on, we can see, before we take the modulus, this will tend to 0. So as we go on and on, we see that the limit will be equal to negative 5. Alright? Now, the modulus of that limit is 5. Now here, as we go on, as n goes on and on, gets larger, 7 divided by n gets smaller and tend to 0. And the limit is negative 5, but the modulus of negative 5 is 5. Right? So the modulus of that limit, we found the limit as negative 5, and we found the modulus of it to be 5. Now the limit of the modulus, if we always continue to take the modulus of this is negative 2. The modulus of this is 1.5. The modulus of this is 4.5. And the modulus of negative 5 is 5. You see the same 5 come up again. So if we take the limit of the modulus, or we take the modulus of the limit, we get the same number, which is the modulus of that limit. Alright, so that's the fourth one. What about the fifth? The fifth result here. What's this talking about? If an is greater than or equal to 0, then the limit of an is greater than or equal to 0. What basically means is that it will not turn from positive to negative. And if you look at the graph of it, for example, 1 over n, the graph of it would be somewhat like this, and the answer for 1 over n, as n goes from 1 to 2 to 3 to 4 and so on and on, the curve would get closer and closer to 0, but will never cross it. The thing is, the limit must be greater than or equal to 0. In other words, the limit will not become negative. The only way you can have a negative here is if the curve crosses 0 and goes into the negative region, which will never happen. Alright? Another example, if we have, say, 1 plus 1 over n. 1 plus 1 over n, right? At first, A1, the first term would be 1 plus 1 over 1, which is 2. The second term would be 1 plus a half, which is 1.5. The third term would be 1 plus a quarter, which is 1.25, and so on. The 100th term, A100, would be 1 plus 100th, which would be 1.01. The 1000th term would be 1 plus 1,000. 1,000, which 1 plus 1,000, which will be 1.001, and so on. So no matter how you go, you will never drop below 1, nor touch 1. Here, no matter how far you go along the calculation, as n tends to infinity, 1 over n tends to 0. And if you plot the graph, and this is 1, you will get closer and closer to 1. If you plot a line x equal 1 here, this line is the line x equal 1. The curve will get closer and closer to it, but will never touch it nor cross it. So here, the only way it can become negative is if it crosses 1 and crosses the x-axis and goes into the negative region of the graph. So this applies at all times. If the function is a positive function, the limit will not become negative. Alright? So that's the 5th result. We'll look at the 6th result in another video.